Hello, and welcome to another episode of AWS She Builds Tech Skills North America. I am your host, Candace Bohannon. I am a specialist solutions architect working on Q Developer and Kiro. And today I'm really excited to be joined by a couple of our specialists for our episode today, where we're going to be talking about AgentCore Memory, context engineering, all of these very hot topics. So I'm super excited about the show today. Agents are kind of everywhere, Gen AI, agentic, all the things. And so I cannot wait to learn from you ladies. So as we kick things off, can you guys go ahead and introduce yourselves? Tell the audience a little bit more about who you are.
Yeah, sure, absolutely. Hi, everyone. I'm Mani Kanuja. I'm Principal Generative AI Specialist Solution Architect at AWS. I've been with AWS for over 6 years, based out of West Coast in the Los Angeles area. And I'm very passionate about agentic AI. So hence we'll be talking more about, and I feel that memory is one of the really good, important pieces of building AI agents. And that's what we'll be talking about today.
Awesome.
Perfect. Hi, everyone. My name is Akarsha Sehwag, and I'm a Gen AI data scientist with the AgentCore Memory GTM team. And I'm based out of New York, so the East Coast, quite opposite end of the US. And happy to be here and share with you all what we have built with AgentCore Memory, and hope that excites you as much as it excites us every single day.
Awesome.
Happy to be here.
Good. Yeah. Thank you so much. And then I'm in the middle. I'm in Minnesota. So we are literally across the entire US between the three of us. So as we kind of kick things off, I would love to hear a little bit more from people who are watching. Have you actually built an agent, or have you used one? Let us know kind of what you've done. And as you have questions or comments along the way, feel free to drop those in the chat, and we'll do our best to answer those as we go through. So very excited about everyone being here today. So, it looks like we have some excited people. Here's someone coming in from Singapore. Did we just hit GA?
Oh, yes.
AgentCore? Yes.
Wow, yes, it actually went live today.
Whoa. Well, Ankit is very on top of the news. I didn't know that quite yet, but in my defense, I'm catching up from being on vacation last week. So cool. So if someone does want to build an agent, Ashish here has used one before, but if someone wants to build an agent, can you give us just a couple of things that they should consider, just kind of high level, before we start diving more into the memory and context?
Yeah, so there are so many things, right? So when we're talking about agents, at the core of it, it's literally a model who has some tools that it can call. And those tools can be read tools, write tools. It's based on what you provide to the agent, right? So that's one part of it. And then we called, okay, if a model that can perform some actions is an agent, but there is a lot more to it. Because what about memory? Because agents are literally stateless, and until and unless you provide them some space or some design them in a way that they can refer to the memory, provide more personalized responses, and then whatever they are doing, how do you know what they are doing, which tools they are calling? And agents can be, now you can span into multiple agents working together on a task. So there can be like so many design patterns in the way you build it. But at the core of it, I think the few major components, it's not a full list, is to provide them tools, provide them memory, because we'll be talking about that, adding observability to it to understand what the agent is doing, and also evaluation. I cannot emphasize enough on the evaluation side of the house, because you cannot go into production if you don't feel confident about your agent. And then you have to deploy it somewhere. So runtime, which is very important, I feel that you need to do that. And security, like, what about
Guardrails.
exactly, guardrails, and how do you authorize a user and make sure that agent can only access to the resources that it's supposed to. So there is like lots and lots and lots of things, but I'm just pointing out some of the things at a high level.
Sure. Yeah,
I think all of these topics need a deep dive of themselves.
And definitely we have that. We'll share some of the resources in the end.
Yes, awesome. I will say last week, I believe it was last week, I did a show and I got to be the demoer and I showed custom agents in Q Developer. And we showed a few of those different things, like how can you have different MCP servers? So the tools that you're talking about, how do you know where they're getting what they have access to as far as bringing that context in? So that was more of a almost like, it kind of gives you a framework to build out those agents for you. And I thought those were very cool. But I'm really excited to learn more about what you guys are going to show us today. Context is such an important piece of it. And the memory piece, people ask me in my job all the time, are we doing things to help with context? What about the memory? All of these sorts of questions. So I've been dabbling in AgentCore, and I'm just really excited to learn from you guys today. So when we start talking more about this, so we're talking about context-aware AI agents with AgentCore Memory. That's really our focus. Our 1 hour today can be on that. So let's talk a little bit more about context and how this is a little bit different from RAG. We've had RAG for a while. So can you double click and take us down a little bit further into this context space?
I think so. This context space is fairly new that we have started talking about. Till now, our industry was very focused on achieving the technical breakthroughs in the agentic AI development. So we were focused on creating these complex workflows of how can we have multiple agents orchestrate, and how can we have extensive tool sets, capabilities. But I mean, overall, however good our agents are in giving human-like responses, they still lack that statefulness. So they are fundamentally stateless, and that's why we have context that brings us that that relevance to the model. So what exactly is context engineering, right? Think of it this way. We have so many different types of information that we can give to our models, and how we engineer that context directly impacts on how good responses we get, or how much hallucinations we get, So these agents are handling these complex tasks. They're having these long-running sessions, research agents. We have so many sequential tool calling, parallel tool calling. There's so much context window that keeps piling up. And that's why we need to understand and minimize the context, the information that we are giving to the model, so that they are able to make a good decision with the right information. They're not getting confused within so much amount that we have provided them with. So we can have different domain knowledge, we can have, so much instruction sets, we can have tools. And one of the key elements, and the main topic also that we are discussing here today, is about memory. And this is where we are, trying to give the human-like experience, human-like connection that the agent can provide to our users.
Yeah, I think we also have a visual. Can we just pull that up?
Got it. Here we go.
Yeah. So I think this is all what you were talking about, Akarsha. And I think, seeing the visual actually helps in connecting all the dots on, how memory is a key component. And when we are talking about those comprehensive instructions, and Candice, you mentioned about, RAG. So when I see the doc on the first line, it's like literally retrieving the relevant documents from your vector store. That's one piece. That's more like a static information. For example, it can be, if you're in a legal domain, that can be contractual information. If you're in HR domain, that can be policies and all. And then the tools are where you want like real-time access to your data. That can be via the data APIs or other functionality that you want to give to your agent, right? And then Absolutely, comprehensive instructions can be your, system prompts, and trust me, that can go really, really long. And you all already touched base about domain knowledge and all. The idea is there is so much context, but what to give to the large language model or our LLM in their context window so that we get the accurate responses is what we call as context engineering. Literally designing a system on how this context window should look like given a specific query to the agent. And as Akasha mentioned, we'll be talking more about memory today and how that plays a role, because that's a really amazing question on we have documents, we have tools, and now memory. What is it, right, Candice?
Yeah, exactly. It feels like there's a lot of different things that we have at our disposal now. We have all of these tools, which is very exciting. But how do we actually know which is the right thing? Like, when do we use RAG versus memory or a tool or something like that?
Yeah, so RAG is more about like static documents, right? So you have like policy documents that I was talking about if you're in the legal system, or if you're building a agent for HR stuff that can have have those HR based policies, or if you're building a travel agent, then you can have documents around that. The documents that don't change too much in time, but you might want to keep updating those documents with new versions and all of that. So that's where you will use RAG. For information that's like really dynamic information, like in near real time, that's where you will use the tools. But then there is memory. And while you are interacting with the agent, and the information that the user is actually talking and providing that context is where memory comes into play.
Awesome.
So let's jump straight into that because we've been talking about memory, memory, memory. So let's let's actually share what is it, because memory actually, if you look at the industry term, is about short-term memory and the long-term memory. So this is a common term that is being used. But if you look at the short-term memory, and that's what we have with agent core memory as well. So what we have with the short-term memory is literally like your raw events. Events is basically the messages that we are talking about, can be between a user and AI assistant, the tool calls, they all can be your events, right? Even literally storing an entire agent state in a blob fashion is also, can be your event. So short-term memory, think about as raw storage where you're storing all these messages, but they are persistent. So the short term is not like it will go away in a few minutes. It's more about giving you the flexibility with agent core memory, whether you want to store it for 7 days up to 365 days, and you can provide that time to live for the short-term memory. And then whatever information goes into the short term memory, if you enable the long term memory, again, you can use either short term or you can use both. But if you enable the long term memory, then the way it works at a high level, and we'll go do a deeper dive in a moment, the way it works at a high level is whatever raw events are there in the short term memory, this if the long-term memory is enabled based on what strategy that you are providing, it will extract those events, and we have a memory extraction module which will extract it, consolidate it, and then embed it and then store it in the vector store, those memory records. So I just refer to this processed information as memory records, and those are then available to the agents to call, right? So few concepts that you want to keep in mind. And all those strategies and the terms that I have used, I promise to explain in detail. But for now, let's keep few things in mind. It's all serverless, right? And it has built-in encryption. It has built-in observability. And for the long-term memory, we have a concept of flexible namespace that we will explain when we'll do a deeper dive on the long-term part. Now let's move into the short term. So, as I mentioned earlier, short term can be your conversation or it can be a blob, JSON blob. Why do we need this blob? Because you might want to store the checkpoint or the session state of an agent. And whatever is in that blob when you enable long-term memory, it doesn't go into the long-term memory, right? Because the reason is what you want to store in the long-term memory is the interaction that the user is having with the agent and the tools that the agent is calling, right? But if you're talking about the agent state and all, you might not want to store that. So that's one of the reasons why it doesn't go into the long term, because you have to be cautious about how you are building your memory system, what information goes in it, because whatever goes in it, agent is actually going to retrieve at some point, and it will become very clear when we'll get into the demo part. And just to emphasize, with agent core memory, you can use short term all by itself if you don't want to use long term. And also, you can use both short term and long term. I think I've talked enough, right?
Yeah.
Get
I
into
think
the
I think people need to see.
Yeah.
yes,
Yes.
in
Okay.
action.
Yes. Let's do this. All right. Okay. So, let's start already. Don't be overwhelmed, please. It's a multi-agent system, but we'll try our best to explain it in a very simple way. Okay, so we are here building a Strands multi-agent system that looks something like this. So we have an orchestrator agent that has two agents as tools. So this orchestrator has added tool number one, which is the flight booking agent, which has its own memory hooks that are attached, and similar for hotel booking agent. This has some tools for hotel booking and also has some memory of its own, right? And this is where we can leverage the AgentCore Memory feature called branching. So here, this is just one way, one pattern that you can use for this feature. You can also have multiple different approaches, really dependent on the use case. So in here, we have the main branch that is used by the orchestrator, where all the messages can go in. And then for the flight booking agent, so that it does not get confused with the events that are being, sent in by the hotel booking agent, we want to keep it separate. So we have the flight events in a flight branch and a hotel events in a hotel branch. And how it usually, like how it will look like in when the events are being stored, it will keep events in the main branch, and then from some point on, when the orchestrator agent has called the tool, from that point onwards, you will fork the conversation and you would create new branches. So in here, then you will have a branch number A, which will create 3A, 4A, so on, right? And similarly, 3B, 4B, and these can be executed in parallel. So you are using these two agents in parallel, letting them do their full workflow, do their task, and then get back with the right information. And then you can kind of feed in the final event or final answer into the main branch. So let's see, how is this done in action?
Yeah. So we are basically creating one memory resource, but then because you want to separate the concerns of these agents, you're literally like using branching. Okay, nice.
Yes. Okay, so we start by importing our memory manager from the starter toolkit, which is essentially responsible for our resource management. So this is where we are creating a memory resource, right? So we start with creating a resource for the memory manager, which called a get or create memory API, where we just provide a memory name, an event of expiry days, and this is the parameter that you can define during the memory creation, which can control how long would the events in the short-term memory live for, because you might not want to store those events for a longer period of time. So you can define them as short as 7 days or as long as 365 days. And once it creates the memory resource, it provides you with a memory ID, and this is the ID that you propagate further on. And this ID stays constant, so you can usually store it in an environment variable or in a session, in a secrets manager or so.
So
Now,
I have a quick question. Sorry. So when you're saying get or create memory, and this will only create the short-term memory?
So this right now will create only the short term because we have not defined any long-term strategies.
Okay. And that's coming up, and you show that,
That's
right?
yes,
Okay.
correct.
Awesome.
So right now we are focused on short term.
Sounds good.
And to now make sure that we are able to send and receive events from, or let's say the memory events from a certain session, we need a session manager. So this we can import from the Bedrock AgentCore memory session, right? So this handles the context of a certain session.
So basically, whenever we are doing like create memory or those like operations, it's like memory manager. But when we are talking about like the data side of the house, and that's where we have the memory session manager. So you're kind of like separating it into two.
Exactly.
Okay.
Exactly. And here we are providing in the resource, so where it should store the events that we are sending in, and then it initializes that. Now, when we are adding this into the agent, when we are enabling the agent to use or to store some memory, we use, in this case, something called hooks. We can also use the tool approach where we can define memory as a tool. But right now we are using hooks, which is also a best practice we recommend to make sure that every time, every invocation, you are making sure that the relevant information is being retrieved from the memory. So how?
Before you go into the hooks, sorry, I have a lot of questions. So I'll keep asking you.
That's perfect. Be inquisitive always.
So you talked about memory as a tool, and then you talk about hooks, and then you also mentioned that hooks is one of the best practices, right?
Mhm.
And why is that so? So, like, what are the pros if I want to use a tool versus what are the pros if I want to use hooks? And then we can go deeper into hooks because I really want to understand that.
Okay. So memory as a tool is essentially you are giving the power in the hands of the agent of when to use memory. Now, when the agent is processing the information that the user has provided it with, it might have the feeling that, hey, maybe I need to check into the memory to get the relevant information if I have any. But since you're providing this in the hands of the agent, it might also not do that. So it might also miss out on the information, right? And that would ruin the customer experience. So
So, for deterministic purposes,
exactly.
hook is the way. And if you're okay with the non
Yeah.
deterministic based on your use case, you can do it, provide memory as a tool.
Yeah.
Okay.
So where you can define the cases, right? That, hey, if the user is asking something about in this context, then retrieve information from the memory. Otherwise, it's not needed. So this kind of optional cases or where it's a bit more dynamic. So you can let the agent decide. Where it's deterministic, we stick with this. Okay. So essentially what hook does is it allows you to have very clear steps in the event, in the agent lifecycle, where you say that this is where you, this is a step where you would retrieve, a memory event or something else. Like you can use hooks for also other usage. So for instance, you say every time you have any invocation to the model, you would want to retrieve memory first. So in this case, we have like multiple wrappers that we have here, which, for example, we say agent initialized event. So every time the agent is being initialized, right after the initialization, you would do certain tasks. And similarly, you can have before invocation. So every time it invokes the model itself, it will do certain tasks and kind of get it prepared for you, you know? So
Can I ask even I noticed you were on the Strands Agents website and we're talking about
yes.
AgentCore, right? I get this question a lot, and so I would love for you to answer it better. But how are these things actually related? They're not the same, but I feel like people get confused a little bit about Strands and AgentCore and how they're related.
That's a very good question. So Strands Agents is a framework to build an agent. AgentCore is everything around it. It's
Perfect.
essentially providing you the ability to use that local agent that you've created using Strands Agent to put it into production. And memory is one of those components of AgentCore.
Got it. Thank you.
Okay, now moving on. So we defined the memory manager with for a certain session. We define then we have some functions which just say, you know, on agent initialized, you have you get a new session or create one, and then basically if it's a new branch, then you list the events for that certain branch. You list the event for the certain branch, and then you are, or if you already have the main events in the main branch, you are initializing a new branch. I think this would be too much in details, but essentially what we want to showcase is that when we have a new message added from the user, so every time a user sends a new query or question, we are calling calling this hook, which is adding the turn. So it is storing that information into the memory store. So into our short-term memory store as a conversational message. So if you remember what Mani mentioned, she mentioned that only the conversational messages are what feeds into the long term, just to kind of connect the dots there. So in this case, it would not, because we haven't defined any strategy. But if you do, you will feed this message type into the long term. And then we can also retrieve the messages from the list events using the list events API. So for a certain branch, we can retrieve the messages and then use them into the context for the agent to use, right?
Can we talk a little bit about these terms too? So when because they're, you know, we have branches and version control and things like that, but I think they go back more to what agent we're calling, and then the turn. So what exactly is a branch and what is a turn when you're doing the add turns? Do you know?
Okay, so add turn is to create an event and to send it into the AgentCore memory.
Okay.
And branching is just a construct to be able to create the separation of concern. So you can only filter events based on a certain branch. So we are talking about a travel agent and a hotel agent. So we can only maybe get information that is relevant to a travel agent, right?
Okay. Thank you.
Sorry, flight agent. Okay, so now we have created a registry for the message added, where we are kind of sending the information retrieving for two different hooks. One is for the message added event, and one for the agent initialized. So every time the agent is initialized, that's when you also tag a memory hook. And now we are going to create the agent itself. So we have a hotel booking prompt, a flight booking prompt, and we are creating a flight booking agent with the hooks in place, with the branch that is gonna create events only for this flight agent memory. And then we have a hotel booking agent, which has the hooks for the hotel agent memory. So here we can then, based on the naming, we can filter out the different branches, different events for different branches. And then we create the agent, add in the hooks, and then we create an orchestrator agent. So the generic,
Yeah, and while we're talking about the short-term memory, I think it will be nice to provide our viewers with some information about the actor ID. I think we didn't talk about that in the session ID as well, right? So if you can provide some intuition around why we have those in the APIs for the short term, I think that'll be great.
That's a very good call out. Thank you. So The session ID is, I mean, quite intuitive. We have been using it for a while. So essentially, session ID is to group a sequence of conversation into one group, right? And now, second aspect is the actor ID. So actor ID is what defines who do these events or the sessions that we have created, who do they belong to? So who is the owner of those events, right? And this could be a user, this could be an agent, this could be probably an organization or a team or a project. It could be anything. So this is the flexibility that we have provided to you, that you can define any kind of actor ID you want.
So in this
And
example, what actor ID are you providing?
so we here are providing, let's look actually.
I think it might be something like agent based or
Yeah,
something.
it's
Yeah.
it's the user. So we have so as we were talking about separation of concerns, right? So we divide the agent information based on the branches. In another world, we could also have, it use that with the actor ID. So we could have done travel user slash hotel or something, right? This could have been another approach of playing, or let's say
Mhm.
tweaking the actor ID. So, and this is how, wait, I will finish yes. Okay. So now that we have the agent nodes created, now we will then group it all together in a graph using a graph builder that is imported from Strands agents. And the graph builder is adding different nodes and then adding edges between them. So there's this overall travel agent that is the entry point of the graph, and that is where it has the capability of calling any of the two agents, hotel booking or flight booking, dependent on what the user asks for.
Mhm. So basically, the orchestrator will store messages in the can store message in the main branch, and then when it's calling like a flight agent or the hotel agent, then they
Mm-hmm.
can have their own branch on the same resource. So we don't have to create the resources over and over again, but just provide them separate branch so that they can work. So it can be like, and I'm again just giving a hypothetical, comparison, like
Mm-hmm.
a working space for the agent, right? But you can retrieve when you come back, and then you can see what you did in the past. Okay, nice.
Yes, exactly. So, I mean, here we are trying to say, hey, I would like to book a trip from LA to Madrid. And then it starts getting some basic details, how many travelers, da da da. And then it basically asks a question back. Okay, there it has actually put it in my hands. But anyway, for now, I mean, we can view the memory branches. So here you see for flight agent memory, we have 3 events that were created where it queried the flight agent, and it queried the hotel agent, not queried, created the branch for the hotel agent with 3 events in there. And then the main branch has 8 events being created.
Mhm.
So you can also retrieve information only based on a specific branch.
Cool. There were a few questions coming through here, but first I just want to give you a compliment from Schizophrenic Web Developer. You're very professional, Akarsha, and probably a good person. So thought I'd throw that in there first because he or she also asked this question.
Yes.
Any other languages supported besides Python right now?
Yes, I think they are supported. We have uh, Java and stuff, and we can provide you link on those other languages. Whenever we release any SDK from AWS, we do support other languages as well. So we can provide you a link.
Great. Thank you.
Okay. Should we move on to the long-term memory? I think that's personally my favorite part.
Yes.
Um,
And when
yes.
we do that, Let me just summarize, Akasha, what you shared for our viewers so that they understand what all we did in that amazing notebook that you shared. And that
Okay.
notebook is actually available on GitHub as well for you to try it out. So, the main idea for this notebook was to create a multi agent and how they are going to interact with the short term memory. We demonstrated one pattern where you can use different branches for for having the separation of concern between these agents. And also for multi-agents also, you will see that there are so many different patterns. One can be that I can call agent as tools. We have that example as well if you're looking for that. But in this one, we wanted to share the graph example because strands, as Akasha mentioned, is a framework and that supports graph as well, where you can actually define whether you want the agents to work in parallel, sequential, based on certain conditions. So you have the flexibility of defining what your flow will look like when you are, building that agent. So that's where graph comes into play. And then we talked about, okay, we have short term memory, we have different branches. Then we talked about what are actors, what are events, what are the conversational, how we add turns. And most importantly, we talked about hooks. And Akasha, thank you so much for clarifying that because to be honest, I always get confused with those hooks and all. And now you have shared, those are literally the event based, based on like where I have this agent life cycle, and based on at which point in time I want to make a call to my memory in this case, I can do that. And that also gives me so many ideas on how can I add other stuff as well. But I would also want to hear it from my viewers if they have got some ideas on how to use hooks. If yes, feel free to add it in the comments. I think we'd love to hear from you as well. So, and then you shared the whole flow on how that worked, and how you added the memories, how you added the branches. You can list the events by a particular branch, or you can actually, we can also see like all those events that were stored in which branch. So that was really nice. So I love this, and I think, Akasha, I'm ready to move into the long-term memory concepts, and then we
Let's do
can,
that.
yeah, and then we can show, I know where you're getting at. We can show other stuff as well.
I wanted to show it a bit more visually,
I
but
know,
okay, we
I
do that.
figured
We
that
do
out.
that.
Yes.
We do that together. Yes.
Okay.
Okay.
So now let's move on to the long-term memory. So with the long-term memory, we have three built-in strategies. And what is this strategy, right? So the first part of the flow, the agent, conversational blob, and then there is like short-term memory. We are putting chat messages, checkpoint, session state, and all of that, right? And now let's say I have enabled a long-term memory. And also we talk, but enabling a long-term memory, what does that mean? So that means providing some strategy, because remember, this extraction module that we have is only triggered when you have long-term memory. But what is it going to do is dependent on the strategy that you provide. For example, if I just want to extract the user preferences from this short-term memory, then I have to provide that strategy. And then if I just want to have a summary per session, then I have to provide that strategy, because how will our workflow or a pipeline would know that what you really want, right? So that's the main point, and that's what a strategy is. But now within a strategy, how do I organize my memory? That's where there is a concept of the namespaces. And namespaces are very flexible. We can have three variables that you can pass into a namespace. That can be strategy ID, because you're creating a strategy. That can be actor ID. That can be a session ID, right? I know there's so many IDs, but it's really giving you the flexibility. If you don't want to use, let's say, strategy ID, but just want to have your user preferences with some hierarchical namespace like uh, /user /preference /actor ID, because you want to know which actor, where are you organizing the user preferences for money, or where are you organizing the user preferences for Akash or Candice, for example, right? So you should be able to organize those and still maintain again that kind of logical separation of concern that we talked about, right? Because we don't want the agent when I'm talking to the agent, it should only be able to access my preferences, right? So those are the things that, namespaces is one of the construct that helps you organize the memory. The one example, or the that I give for just the visual purpose in your head, because I'm a very visual person, I think of long term memory is like, okay, there is this empty whiteboard, and then I can have like different sections of the whiteboard. um, and if I'm working on a particular section on the whiteboard where I'm storing my preferences, that's only visible to me, right? I know that's a very uh, hypothetical whiteboard, but it's just for, yeah, giving some idea about how you organize these memories within the long term. So that's why you would see that async, because this extraction module is literally like a pipeline. And this is asynchronous, and I'll give you more details about that. But once you have the memory records in your long term memory, then you can use like retrieve memory records, list memory records. You have so many APIs, and that's a synchronous process, because once you have the messages into your long term memory, you just call the API, and you should be able to refer to it or extract it or search for it, right? So the main thing between difference between retrieve memory record and list memory record is, with the retrieve memory record, you can provide the query, and then it will search, it will do a semantic search on the memory itself. And you can also provide like a top K, like how many closest memories you want to retrieve based on the user query. Whereas list memory record, you can provide just the namespace without any query, and it will just list all the memory records. You have the ability to provide max results, because it can really grow very fast, right? So just wanted to highlight those differences. So I think we need to dive deeper
Mani,
into the
what,
extraction. Yeah.
a question though. What if I wanna, I don't know, customize it for my use case?
Oh yeah, absolutely. So with the long-term memory, we also have override strategy. So what that override strategy can do is, let's say I still want to use preferences, but I want to have my own model or my own prompt. Prompt is basically instructions, right? On how I want to extract the memories. And behind the scenes, there are LLMs in the memory extraction module. So you can actually do that. You can change the model, you can change or customize the prompt, and then have this override strategy. So that's another way to have the long term memory and the override strategy. And I think we should do a deeper dive into the memory extraction module, right?
Hmm.
Okay. So when we're talking about memory extraction module, you have this, as we have talked about, the short-term events, and Akasha has already given a demo of how you will build your agent with short-term memory. So now just assume we are at this point of the demo where the events are already there in the short-term memory. Now, but in Akasha's demo, we didn't provide it the strategy, and that's what we have as our next demo, that we will provide a strategy. And then after every K messages or X seconds of inactivity, it can actually start automatically. You don't have to do anything. You just provide the strategy, you create the memory. It will automatically start extracting the information from these raw events. And what it will do is, and this is per strategy. So one is the extraction module, where I have some instructions, and there is an LLM which basically will take these raw events based on the instructions like user preferences or summary. It will extract the relevant thing, and then there's a consolidation, and then embedding and indexing. But let me talk about consolidation, and I'll take an example of user preferences when I'm talking about consolidation. So let's say when I was talking to the agent, I shared that I'm a vegetarian, right? Okay, let's do the other one. When I'm talking to the agent, I shared that I'm a non vegetarian. The reason is because I was born in a non vegetarian family, and I've been eating non veg. That's actually true up until I was in my 20s. And then, because at that time, if I was interacting with the agent and I wanted like food options and asked to search for the restaurants, I would want the non vegetarian options or the seafood options, right? So I provided that, and the agent knows about that. And ever since we were best friends, where agent was recommending me all those amazing restaurants, right? I bet everyone would be hungry by now. So so now, but when after my 20s, late 20s, I decided to turn into vegetarian by choice, right? So now I'm a vegetarian. And now when I interact with my agent, I don't like when it suggests me the restaurants which don't serve vegetarian food, right? Because that's the last thing that I want, like to just appear at the restaurant, have a booking which doesn't even serve any vegetarian food, right? So the agent should be able to update that preference. So let's walk you through this. So initially, Money was a non vegetarian. Money provided that information. Memory extraction module came in. The extraction module extracted Money's user preference, food category, all of that is non vegetarian. And then it goes to the consolidation and it says, oh, let me retrieve, do we have Money's food preferences or not? It's like, oh, Money doesn't have any food preferences. Let's add non vegetarian. So it will then go to the add part, index it, and store it in that vector store. Now, after 20 years, Money comes back and says, I'm just kidding. Let's say after a year, Money comes back and says that, you know what, I'm a vegetarian now. And then the memory extraction module kicks in and says, oh, Money's preference is vegetarian, food preference, blah, 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 those categories, goes to the consolidation logic. The consolidation logic goes into, okay, let's fetch Money's food preferences. Oh, Money's food preferences were non-vegetarian, but now it's talking about vegetarian. Oh, let me update that. So that's where the update logic will kick in, right? And then the embedding, indexing, everything will get stored. And then I come back after, let's say, another 10 days or 15 days, and I say, hey, I'm a vegetarian. And then it goes to the extraction thing, food preferences, and then the consolidation logic kicks in and it says, oh, Money food preferences, vegetarian. Oh, it's the same. Then let's not do anything. Let's skip it. So that's where this skip, add update skip comes into play. It will not do anything then. It will just skip because it already had my current preferences which matched, right? So this is very important concept to understand and what all happens behind the scenes for long-term memory to get populated. And that's the reason why we call it as asynchronous, because it takes up to 30 seconds for this memory to get populated. Again, it's dependent on the number of messages and all. Sometimes it can be faster as well. Much information. Let's see it in action. What do you say, Akasha and Candice? You want to see it in action, whatever we have talked about?
Let's see a demo.
Yes.
Yes.
I'm going to post just really quick. Here is the banner for the GitHub samples where this is all coming from to answer, I think it was Miro's question. And I'm trying to paste it also into YouTube right now, but I'm struggling with signing in. So I will have it for you in that chat in just 1 second as well.
Thank you. Okay. All right. So now focusing on the long-term memory. So what we have here is an agent with a couple of tools that we have provided with. One is a web search tool that uses DuckDuckGo to search the web. And the second is checking order status, very simple tool, just to understand where the order is at. And then what we are doing here is using the same hook approach. We are storing the raw events in the short-term memory, and it should automatically extract the long-term memory for the strategies that we have defined. So in this case, we will define the user preferences and a semantic strategy. So let's take a look. Similar approach. So I think with this, we have discussed already of how do we create a memory session manager and a memory manager. Exactly the same approach. The only thing we change or we add here is the strategies. So strategies is a list of dictionaries that we can provide to add different strategy types. Now, you can take one of the predefined ones, or as Mani said, you can also override. I'll briefly show the override one. But first of all, to take the value, we take in the strategy type, and we define a name to it. This could be anything that you want to call it as, any description that you want to provide for yourself to understand what exactly is being stored in there. And then the important one, namespaces. This is what Mani has described. And in here we are so the variables you can put in, there's 3 variables you can add: strategy ID, memory ID, or the actor ID.
No,
Sorry,
strategy.
session ID.
Yeah.
My
Okay.
bad. Sorry.
No worries.
Strategy ID, session ID, and actor ID. And in here we want to create this hierarchy based on the actor ID. So we want to separate these events that are the memories that are going in based on the actors. So different actors should have their own namespace, right? And that's why we provided this variable. Now you can also do that for strategy ID. I could also extend it with a strategy ID or so. But in this case, let's keep it simple and just keep a actor ID, right? And this is the same for the semantic strategy that we provide. Here as well, we are creating a namespace with the actor ID. And now when you're creating the roles, so when you're creating the access control, you can only give access to a certain actor only for this. And then how you would get this actor ID in when you're running this in a runtime environment, or in any ECS, EKS, or any other compute. So usually when you're interacting with the front end, you get this from the authentication. You get the information about the user, who is being authorized to use this application. So that's where you kind of can feed it into this application. Okay, so before we start on creating the memory, I just want to showcase how would you create a custom strategy. So there is, yes, here. So here, for example, we can also create a custom user preference strategy. So this will override the user preference strategy. Right? So here you can define the extraction config of what should be the extraction prompt and the model ID. And you can define in similarly the consolidation config with the consolidation prompt and the model ID. So this way you can customize, how do you want to extract and how do you want to consolidate? And based on that, the extraction and based on that, the pipeline will change. So this, for example, you can only focus on food preferences or so, right? You don't, maybe you don't care about what the programming preferences of a user is. So you just want to focus it based on the use case. Okay, so now same procedure, we create or get memory, but in here we define the strategies. So we add this parameter for strategies. And then it creates the, based on the name that we define, it creates a semantic and the user preference strategy. Then you can retrieve those strategies of what all exists, and then let's create the agent. So we create the tools, web search tool, and the check order status. It has some mock orders that are put in place that just retrieves. Now, to create the memory hooks, we have the exact same approach as before, slightly tweaked. So in here, we will also now search for the long-term memories. So before we were only retrieving events based on a session ID, but now we are also looking into the long-term memories and retrieving that information. So based on what the user has asked for, we will provide the prefix of which namespace do you want to search in, and then ask it to retrieve three relevant memories from that namespace, right? And I mean, if you want to do all of the namespaces for semantic and user preferences, you can loop in, like you can create a for loop and then go through all the strategies, or you can just specify based on different maybe on agent initialized, you want to retrieve the user preferences. And on every message that is every new message added event, you want to retrieve perhaps a semantic based on the query that the user has provided. So this you can tweak based on what application, what use case you are building. All right. And then all in all, once you have retrieved all those memories, you're injecting that into the context of your message. And based on that, you should be able to add that information into the query that is being sent to the LLM. So every time a message is added, this hook will run and it'll add that context. Similar for after invocation. Now, once the LLM has responded back, you want to store what has the user asked, what was the response. You want to store that in the memory, right? And in here, then we can call a add turn call, and we can define that for this actor ID, for this session ID, store these messages. And we can
This
define.
is exactly the same as you shared in the short term.
Yes.
So I think I'm very excited to see like the thing in action. Like, okay, we have the short term, we have enabled long term, we have added the hooks. Now what? Let's just see it in action.
And we are down to like 2 minutes. So 3 minutes. Time flies.
Okay. I mean, so we can add it into the conversation and all. What I want to showcase is, let's see it visualized, because I think that's really gonna help on to see how these preferences are being stored, right?
Yeah, absolutely. And also, like these notebooks are available for you to try it out. And Akasha has explained some of the really important concepts in the notebook. Adding it to the agent and calling the agent is literally the same that we talked about in the previous notebook. But this concept, how do you add the strategy? What are the best practices? How you define the hooks and where do you call that is super important, which Akasha, you have explained it in detail. So thank you so much for that. It's clear to me, like how am I going to design my next agent and add memory to it? And I'll keep in mind those context engineering stuff that you talked about and shared with us in the beginning.
Perfect. Just give me a second.
Yeah, take your time. I know what happens is, and this memory browser is also available. The thing that happens is like when we are doing the demo, it's actually on for quite some time. And what happens is like there is behind the scenes, like a session would get expired and all of that. So things like that can happen. But even this browser that Akasha is sharing is actually on this GitHub. So you can try it on your own as well.
Yes.
Session ID, Akasha, you're missing the session ID.
Yes, I'm missing the session ID, which I'm trying to find.
It always gets stressful.
Yeah.
Live demos, so fun.
Okay, but overall, when we are trying to add this into the agent, we can, for example, we can add the information. For example, here we have seeded some previous interaction, just some information about, hey, I have Sennheiser headphones, I have iPhone 15 Pro, and I like ThinkPad laptops. So this information, then the agent should be able to retrieve. And for example, here I say, hey, I'm interested in buying a laptop. What models do you recommend? So it's able to say, let me search of the ThinkPad models and provide you with recommendations. So then it comes up with ThinkPad recommendations, so that I don't have to every time provide every detail of which preferences do I have. So I can ask more, let's say, conversational questions.
Yeah, absolutely. And just to recap what we have all shared, because I know we have only 30 seconds left. So today we started with context engineering, and then we started with an amazing question, Candace, that you asked, because that was so important, like RAG and how do we define, how memory plays into role memory plays, and tools. So we talked about that. We talked about short-term, long-term memory. Short-term memory, we did a deeper dive on the branching. Then we talked about long-term memory and different strategies, so on and so forth. We did a really good deep dive on the hooks because that was a common question that everyone has been asking. And then we did a short-term memory branching multi-agent example. And with long-term memory, it was a single agent preferences example. And we did a deeper dive on how to add the hooks and what's different from the previous notebook. So would absolutely recommend everyone to try that out. And also another thing, I know we are on time, that I forgot to mention is that we did a recent deep dive, I think last week on memory, where we showed absolutely different examples. And we talked about the memory concepts a lot more in detail. So I would recommend definitely, along with this, definitely try, watch that video as well. It's available for you on YouTube, Show and Tell Agent Core series. It has memory and other Agent Core services as well.
Awesome. Okay. Well, before we get yanked off, I just want to thank you both for your time today. Thank you for teaching us a bit and walking through that notebook. I think it was great. And to all of our viewers, I hope you learned something, and I hope you join us again next week here on Twitch and YouTube. I think we're talking about QuickSight for the next couple of episodes. So I hope you can join us again soon. And thank you again, Mani and Akarsha, for being here today.
Yeah.
Thank you so much for inviting. Hope
Bye, everyone.
everyone liked it as well. Bye-bye.